Up to now in chapter 4 with the if statement, what we were doing was evaluating whether a condition was true. And we would only act in the case that a condition evaluated as true. That's what the if statement gets us. Moving forward here with 4.4, this is on page 168. In 4.4, we have the if-else statement. In an if-else statement, we have two discrete ideas. The first is to do something, to execute a statement block, when the condition is evaluated as true. And what we're adding is the else statement. It's not elf, it's else. We're adding the else statement to this. What we're saying is, if this condition evaluates as false, to do this other thing. So here in 4.4, this is program 4-8. I'll just kind of elucidate what's happening in here. We are looking for essentially a report. We are going to report to the user whether or not a number is even or odd. So how do we determine if a number is even? So I'll let you, again, avoid your early mathematical PTSDs. And the easy answer here is, the easy mathematical answer here is, if a number is divisible by 2, it is even. If a number rather is not evenly divisible by 2, it is odd, right? I think that meets everybody's simple expectation for how can we mathematically check if a number is even or odd. So this turns out to be a good use of the if-else statement. I want, in one case, that a number is divisible evenly by 2 to make a statement, this is even. And I want, in the case that that is not true, a number is not evenly divisible by 2, I want a separate, different, alternative statement. I want that statement to say that this number is odd. So we have here in our simple, very short program, again, this is 4-8, and this is on page 168. So we have in lines 11, 12, and 13, we are asking for the user to enter a number. We are having them enter, in this case, an integer number, so whole numbers, because that's how we get even and odd, right? Because we're not worried about that when we have fractional decimal type numbers. So our number should be an integer here, just so you're aware. And then on line number 14, we have our if statement. So what we want to do is check that entry number from the user and see if it's divisible by 2. Now, we've been skirting around the outside of the modulus operator, and we can see that here. It's on line number 14. So we have number, the percent sign, 2. What that says is, number percent sign 2 equals 0. I just want to walk through that so you can see everything that is happening. So the first thing we have the entry number, and then we have percent 2. So what we're doing is we're making an evaluation there. So what we're saying is, if I can divide that number by 2, and I will get a remainder. That's what the modulus operator does. It gives you the remainder of something. So if I enter in 2, 2 divided by 2 doesn't have a remainder. So that is 0 is the result. So we've got the equals there. That is our a relational expression, right? So it's not equals 0, that's an assignment. The equals is a relational operator. It's saying, okay, is it true that there's no remainder 4 divided by 2? That's right, there's no remainder. It's simply 2. There's nothing left there. So that equals 0. So that expression evaluates as true. If line number 14 evaluates as true, line number 15 is executed on. So Let's run that back. And this time around, we're going to enter 7 as number. So the user enters 7 and line number 14 in the normal flow of things, top to bottom, left to right, exclusively in that order. Number 14 is the next line that is evaluated after the user makes their entry, number 7. 7 divided by 2 does have a remainder. It has, right, it's 6, and then the remainder is 1. So that expression, number 14, line number 14, does not evaluate as true. So it goes down to the else statement. So in the else statement, it's whatever is not true happens here in the else. The rule here is the same as it was with the if in 4 dot, I think it was 2. It's the one line of code that precedes the else statement, in this case, would fire. So it says the number is odd. Now, do we have the same rule here where we can only have one line of logic that follows our if-else statement? No, we have the same rule as before from 4 dot 3, it's not a dash, it's a dot. I keep doing this today. In 4.3, where if the line that follows, rather, an if statement is a statement block, so an opening and closing curling brace, then the statement block executes as if it was the one line. The same goes here. I always suggest the lines that follow an if statement should be an opening and a closing curly brace. The lines that follow an else statement should always be an opening and a closing curly brace, because what we want to do is have a statement block after those conditions, even if temporarily the only line of logic we have there is 1. We've added 2 for just extra stuff. It is better to have them there and get in the habit of adding those statement blocks after our conditional statements, because it gets you in the habit of thinking about code as statement blocks, automatically enclosing code in statement blocks, and saving yourself from the heartache later of having to come back and find where your logical mistake was because you made a mistake about how many statements follow an if or an if-else statement. And C++ won't make that mistake.